Welcome to all. I am Sumathi from PG Department of Mathematics, Sitalakshmi Ramaswamy College, Trichy. In this video, we are going to learn how to solve connected problem in graph theory using Kruskel algorithm. Connected problem is a classic problem in graph theory in which we find the minimum spanning tree. Several algorithms can be used to solve the connected problem in graph theory. Here, we are going to use Kruskel algorithm. It is a popular algorithm in graph theory. It is used to find the minimum weighted spanning tree. What is meant by graph? Graph is a collection of vertices and edges. Weighted graph. Weighted graph is a graph in which all the edges having some weights. Tree. Tree is a connected graph having no cycle. Spanning tree. Spanning tree is a tree in which all the vertices of the graph will appear. Minimum weighted spanning tree. Minimum weighted subgraph that contains all the vertices of the graph. Kruskel algorithm. First, we start with sort the edges and then initialize the minimum spanning tree. Iterate through the sorted edges. Add the edges one by one. If the edge does not form a cycle, add it to the minimum spanning tree. If the edge belongs to the cycle, then we neglect the corresponding edge. Repeat until all vertices are connected. For this, let us consider one edge-weighted graph. This graph is having 7 vertices and 12 edges. For this, first write the weight of the edges in increasing order. Here, the edge FG is having minimum weight 1. Therefore, we select FG first. And then 2 edges having minimum weight 2, BE and DE are the edges having minimum weights 2. Therefore, we select 2 edges BE and DE one by one. Next, 3 edges are having the weights 3. Therefore, we select one by one. First, if you select DF, then we get this one. Next, we select DD and DG. If you select BD, then BED will form a cycle. Therefore, we neglect BD. Similarly, if you add EG, then D, E, F, G form a cycle. Therefore, we neglect BD and GE. Next, the edge DG is having the weight 4. If you add DG, then DGF will form a cycle. Therefore, we neglect DG. Next, 3 edges are having minimum weight 6. Therefore, we add one by one. First, we select AD. Next, suppose we are willing to add AB first, then A, B, E, D will form a cycle. Therefore, we neglect AB. Next, we add the HAC. Now, we will get a spanning tree. It contains all the vertices and having no cycle. Therefore, we stop the selection of the edges in the graph. This is a spanning tree. This spanning tree contains all the vertices and having no cycle. Therefore, it is a minimum weighted spanning tree. Applications. The connector problem is very much used in network design, VLC design, and clustering. In network design, it is for designing communication networks, transportation systems, and logistics networks. In VLC design, it is for designing very large scale integration circuits. In clustering, to cluster data points in machine learning and data analysis. Thank you.